Alright, Unit 1, 1.1, Rectangular Coordinates, Graphing Utilities, Introduction to Graphing Equations. Okay, anytime you see an example in these notes, those problems I will do out in these videos. Anytime you see a you try, like the one up here, I'm not going to be doing those problems in those notes, in these notes. I'd like you guys to try to do those on your own. Because this is the first you try problem, I will do the first part for you. So let's see here. It says plot each point in the xy plane. Tell in which quadrant or on what coordinate axis each point lies. So first thing, let's draw our xy plane. Look something like this. I will plot the very first point. Actually, hopefully you guys remember the quadrants look something like this. It's first quadrant, second quadrant, third quadrant, fourth quadrant. This is the x-axis and this is the y-axis. So the first point is negative 3, 2. There it is. It is in quadrant 2. There you go. Go ahead and plot the other 2 points. Alright, example 1. Find the coordinates of the point shown in the figure below. Assume the coordinates are integers. So we're looking at this point here. This looks like negative 2. This looks like 1. So I'm thinking it is negative 2, 1. You guys can do this one. This one says to tell what quadrant it is. This one doesn't, but it's quadrant 2. Okay, find the distance between the points 1, 3, and 5, 6. Okay, so 1, 3 is here. 5, 6. 1, 2, 3, 4, 5, 6. 5, sorry. 5. 1, 2, 3, 4, 5, 6 is here. Now, some of you guys might remember the distance formula. Great, go ahead and do it that way. If you don't, another way you could do it is with the Pythagorean Theorem. And that's how I'm going to do this particular problem. We can use the Pythagorean Theorem because I know this distance and I know this distance. So I can just go, okay, 1, 2, 3, 4. So this is 4. 1, 2, 3. This is 3. Now, if you remember your Pythagorean triples, 3, 4, 5 is a common right triangle. If you don't, that's okay. Just use the Pythagorean Theorem. Yep. 3 squared is 9, 4 squared is 16, and the square root of 25 is, of course, 5. So the distance between them is 5. Okay? Alright, now, the distance formula between 2 points, P1 and P2, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now I'm going to do the proof down here. Okay, so let's imagine that, kind of like what we had up there, we've got 2 points in the xy plane. Doesn't matter what they are. I'll call this one x1, y1, and I'll call this one over here x2, y2. Okay? And I want to know this distance. Imagine that line's straight. Sorry. Let's use a different color. Okay. I want to find this length and this length. If this here is x1 and this is x2, then this distance is going to be x2 minus x1. Okay? If this is y2 and this is y1, then this distance is going to be y2 minus y1. So if you think about it, this is like my A and this is like my B. So I have a squared plus b squared equals c squared. My A is x2 minus x1 squared, and my b is y2 minus y1 squared. Now to get rid of this squared, I've got to take the square root of both sides. So my c, or my distance, is the square root of x2 minus x1 squared plus y2 minus y1 squared. That's how they get the distance formula. It's basically the Pythagorean Theorem, just with all the steps already out. So if you are really not very good at memorizing equations, most of you guys probably already have the Pythagorean Theorem memorized. You can always just graph it out and do it that way. Okay? Alright, find the length of the segment shown in the figure below. Alright, I am going to use the distance formula here. So I've got x2 minus x1 squared plus y2 minus y1 squared. I'll make this one x1, y1, and this one x2, y2. It actually doesn't matter which one's 1 and 2, as long as you don't accidentally put x1, y2 over here and x2, y1 over here. Make sure that each point is has a unique number. Alright, so my x2 is 3, my x1 is negative 4, my y2 is 2, my y1 is 5. This minus negative becomes a positive. Here, let me do that in a different color. Okay. So this is 3 plus 4 is 7. 2 minus 5 is negative 3. So I've got square root of 49 plus 9, which is 58. Okay? And 58, I don't believe factors. 2 goes into 58 29 times. Nope. So this is as simplified as it gets. Okay? You guys try this one. Okay. This one, unfortunately, I had to split between 2 pages. I apologize for that. That's just how it worked. Consider the 3 points, A, B, and C. Plot each point to form a triangle ABC. Alright, so first things first. Were they all positive? Nope, some of them are negative. So we've got negative 1, 2. Let me change colors. Let's use this one. Negative 2, 1. There we go. 2, 3. And 3, 1. So there. There's our, there's our triangle. Okay. Okay, find the length of each side of the triangle. Okay, well, this one's easy. You got 1, 2, 3, 4, 5. There we go. The other two, we have to use the distance formula. So this one was 2, 3. This one was 3, 1. And this one was negative 2, 1. So let's find this distance first. Let's use that one. So x2 minus x1, I've got 2 minus negative 2. y2 minus y1, 3 minus 1. Minus negative becomes a positive. So I've got 4 squared plus 2 squared, 16 plus 4. This gives me square root of 20. Alright, now 20 is 4 times 5. 5 is prime. 4 is 2 times 2. There are 2 2's. Anytime there are 2 of a number in the prime factorization, you can pull it out. Whatever there's only 1 of stays in the square root. So this is the simplified form. Okay. Alright, and the other one, x2 minus x1, so I've got 3 minus 2. Y2 minus y1, I got 1 minus 3. Both of those are squared. 3 minus 2 squared is 1, or 3 minus 2 is 1. Got that squared. Negative 2 squared, so I've got 1 plus 4. This is root 5. And that's as simplified as it gets because 5 is prime. Alright, so we've found all three sides. Verify that the triangle is a right triangle. Okay, so if this is a right triangle, then this would obviously be the right angle. Let me draw a better box. There we go. The best way to figure out if it is a right triangle is to use the Pythagorean Theorem. So my a squared, remember in the Pythagorean Theorem, c has to be the hypotenuse, the longest side. A and b, it doesn't matter which of these are a, which of these are b. I'm just going to make this one a. I'll make this one b. Root 5 squared is just 5. This squared. 2 squared is 4. Root 5 squared is just 5. So 4 times 5 is 20. This is 25. So 25 is c squared. Take the square root, and it's 5. And what do you know? That is in fact what c is. So it is a right triangle. By the way, I should label these. This was part C. I'll just use the same color. This was part A. This was part B. Alright, last step. Find the area of the triangle. I'm going to do this up here since I don't have any more room down there. If you guys remember, the area of a triangle is 1/2 base times height. Now, if this is a right triangle, we can just make this the base, this the height. We don't have to find any kind of altitude. Okay, so I'll make this the base and this the height. 2 root 5 times root 5. Now root 5 times root 5 is just 5. Half of 10 is 5. There you go. Alright, you guys can try the you try problem. Okay, midpoint formula. The midpoint of between 2 points is x1 plus x2 over 2, y1 plus y2 over 2. Alright, I'm going to do a proof of this also. Let's imagine that in our xy plane we have 2 points. I'll call this one x1, y1, and I'll call this one x2, y2. And I want to find the midpoint between these 2 points. It's going to be somewhere here. Now, I know this is x1, and I know this is x2. The point right smack dab in the middle is going to be the average of these 2 points. And how do you find the average? Well, you add them together, and you divide by 2. Same thing here. This is y1, this is y2. This is going to be the average. The average is y1 plus y2 over 2. So the midpoint, call this m, the midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. And that's how you get the midpoint formula. Alright, so for example, let's say I'm trying to find the midpoint between these 2 points. I've got x1 plus x2 over 2, y1 plus y2 over 2. I'm going to add my x's, so I've got negative 5 plus 3, 5 plus 1. Negative 5 plus 3 is negative 2. 5 plus 1 is 6. Negative 2 divided by 2 is negative 1. 6 divided by 2 is 3. And you guys can try this one.